decimal fractions, remainders. Let's do it. All right, so here we go. Here's our problem. 9.3 divided by 6. I'm just going to show you why I don't want to draw this. Here's my 9, here's my 3. Looks like this. I want to split it up among 6 people. I draw 9 here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oops. Okay. So there's 9. 3 here. Just going to show you. So I'm splitting it equally among 6. That means each person's going to get 1 here, and that's it. And then I'm going to cross all these out, and I got to pull them over here, and I got to draw 30 dots. I do not want to do that. I'm just going to show you that is why I don't want to deal with the algorithm, or I don't want to deal with the picture always. Sometimes picture's awesome. The picture's awesome for helping you understand it. It's awesome if you do understand it that way, but I want you to get to the algorithm and understand that as well. So let's get rid of it. We are going to use the algorithm. I'm going to show you that now. The algorithm is awesome. We set it up, and most of you know how to set this up. It's great that you know how to set it up. I'm going to do a couple things with you. It's really important that you need to remember when you divide. 6 goes into 9 how many times? That's what you want to ask yourself. How many times does it go in there? Well, in this case, 6 goes into 9 only once. Then you do 6 times 1, and you get 6. Here's where a couple of issues come in. You forget to bring down the number. There's a lot of things that we forget. It's 3, and if we went back to our picture, let me delete that. How many did we move over? 3, right? 1, 2, 3, all moving over, right? 30. And if we added them together, how many would we have? 30 plus 3, so we would have 33 in this box, 33 little discs or dots, however you want to look at it. Check this out. I'm going to show you why the picture connects. Let's bring down this 3 because this is the next step. We got to bring this down. 33. And before we bring it down, let me highlight one more thing. This decimal, just move it straight up. Okay, that's really important. Don't forget that. That is super important. Don't forget that decimal. Decimal is really important. Otherwise, you're going to get a number in the hundreds, and you got to ask yourself, if I do 9 divided by 6, if I had 9 cupcakes and I split them among 6 people, would I have over 100? No, I shouldn't. Would I have over 10? No, I shouldn't. So that's why that decimal is really important. So now we have that 33. Remember, back to the picture. 33, right? So that is where that comes in. So we now ask ourselves, how many times does 6 go into 33? Well, it goes in 5 times, and that's 30. Awesome. Bring down the 3. You can guess what would be next in the box. Probably 3. But now do we stop there? This is why understanding how to do the box is important. A lot of you would go here and just write remainder 3. Not a wrong answer. Not what I want. Okay? It's not wrong, but it's not what I want. I want to see, because we can go further with decimals, we can add a 0 here. And when we add a 0, we simply bring it down, and that becomes 30. Let me do that in orange. So that becomes a 30, and then we ask ourselves again, how many times does 6 go into 30, right? 6 goes into 30 5 times. There it is. We double check. Boom and boom. That's how you use the algorithm. That's our answer. How do we check it? We could check it by multiplying 1.55 times 6. I'll let you do that. This answer should be the same as our original problem, 9.3. So awesome job. Check out the next video talking about tape diagrams.